Thank you for joining our webinar series today. This is the start of our Encounter Masterclass series. Ryan holds a PhD in bioengineering from UCSD. He has spent years at NanoString. We typically reserve this for our enterprise and professional users. We've opened this up for everyone. I'm very excited to lead this masterclass. This idea has been floating around my head for years. I want to share all the knowledge I've gained over the past 10 years to enable all of you to be successful in everything you do. And this feeds into the broader mission of Rosalind. So at the highest level, Rosalind is a unified platform for multi-omics data analysis. So that's what got me into science originally. And based off of my experience over the past 10 years, there's a lot I can share with all the Encounter users to help you in your basic science, in your drug development, and just improve the lives of all of us. My main goal to explain to you is what are the basic principles of Encounter data analysis and how do the algorithms work? Because we just released a whole host of new updated features for Encounter analysis. We call this our advanced analysis. So we have new customized pruning, customized normalization. We've enhanced the pathway analysis experience. We've embedded our deep intelligence and knowledge into Encounter analysis to allow you to get your analysis information out of your targeted panel. And of course, you can use meta-analysis and updated cell profiling. Rosalind is at the forefront. It is the place to analyze your Encounter data, whether you're an individual researcher or you represent an institution. It fosters collaboration more seamlessly than anything I've ever seen. Together, Rosalind and Encounter represent a complete end-to-end solution for rapid discovery and deep insight. Again, you start in the lab with 15 minutes of pipetting, overnight hybridization, get your data in less than 24 hours, and that feeds directly into Rosalind, where you can extend the utility of your targeted panel using Rosalind intelligence, Rosalind knowledge, enhanced pathway analysis to get as much data possible out of your targeted discovery. Why do we want to prune low expressors? If this is a new concept to you, I'm going to talk to you about this in depth, why we're doing it. A few bullet points came to mind when I was thinking about this. The first is that you're removing these low expressors to maximize the accuracy and robustness of your normalization. And therefore, by doing that, you can improve the accuracy of your interpretation. You want to ultimately increase the confidence that your data are accurate. So you want to have confidence to publish them, or if you're designing follow-up experiments, you want to make sure that your foundation of knowledge is accurate for these follow-up experiments. But what's new is this advanced path. This is available to all of our paid subscribers, our academic subscribers, our enterprise professional subscribers. And what this enables for you is to customize the pruning of the low expressors, customize normalization as well. And that really sets the stage for making sure you have confidence in the accuracy and interpretation of your data. So from my perspective, having these customizations is, it's a great feature to have, and I would definitely use it in all of my analysis. What we did is we reversed the order of the traditional housekeeping gene normalization and pruning. So if you've done Encounter analysis in the past, you have most likely selected your housekeeping genes first and then pruned the data, removed the low expressors. However, what I observed is that in certain situations, this allows some low expression housekeepers, some housekeepers in the noise, to actually enter the normalization process. And I think everyone's eyes are probably opening right now because obviously you don't want these low expression probes, you don't want this noise data to be involved in your normalization. First, you want to get rid of those and then perform your normalization. So that is why we switched the order. It was very deliberate. We put pruning before normalization so you can make sure you have very robust housekeeping genes prior to your normalization steps. I love Excel, but it's not great for data analysis, as you know. But I want to show you how the calculations are done. I downloaded the raw data directly from the Rosalind platform. What I've done is I've colored data points that are below the limit of detection in this pink color. So here, this graph represents, for samples 1 through 10 on the x-axis, what is the limit of detection. When we look at this first gene, C4BPA, how many of the samples are below this threshold of 15? Now, everything we just learned is going to help us in this page here. So you'll see we have this low count threshold that we can change. We just did that in Excel. We have the sample frequency threshold that we can change that we just did in Excel. And based off of these two thresholds working in combination, Rosalind tells us that there's 60 probes that's recommended to remove based off of these thresholds. So this is the power and the beauty of the Rosalind interface and having this very granular gene level view. You want to make sure you include all of your key targets of interest.
We also have Rosalind Academy. If you are not aware, I would encourage everyone to come here. This is everything Rosalind. We're putting a very strong focus on our resources for Encounter. Our next session is May 2nd, and we're going into customized normalization. So I'll explain the details of how normalization works, different approaches, different strategies, and it'll be very similar to the session we just did. So I will see you then. Thank you, everyone.